Algebra 2, wow, that's terrible. I can't start a video out of focus. All right, take 2. Algebra 2, lesson 74, uniform motion with both distances given. So, this is pretty much a distance, rate, and time problem using advanced substitution. The advanced substitution techniques are something we learned a few lessons ago. Actually, probably about 10 or 15 lessons ago now. And the advanced substitution is learning how to substitute for two quantities at the same time when you know their numerical value. Now, as far as both distances given, we have to again review the different distance problems we have. The first version is where we have, distance A and distance B are both making the same trip. In other words, the equation would be that distance A is equal to distance B. So that's the first version. The second version is going to be where distance A and distance B are being added. Kind of think like a relay race where distance A goes part of the distance, and then distance B goes the rest of the distance. In this case, what we're doing is we're adding distance A plus distance B to get a total. And then the last one is where the two distances are unequal. And we'll make this amount like 50. So in this one, distance A is like 50 miles shorter than distance B. Oops. So this equation would read distance A plus 50 equals distance B. So these are the three different types of equations we're dealing with, and the overall formula that we have to remember, which is key to this whole process, is that distance is equal to rate times time. And once we get our distance equation down, we're going to substitute all these distances for rate and time. So this first equation can be written as rate of A times time of A equals rate of B times time of B. And I'm going to use some magic to speed up time really quick. Ta-da! Now you didn't have to see me write all that out. But using this distance equals rate times time, we can rewrite all of these distance equations in terms of rate and time. Distance A being replaced with rate of A, time of A. Distance B being replaced with rate of B, time of B. So understanding these concepts of substitution and these three different types of distance formulas is key to getting these problems right. So if you don't understand this, then this is where we have to start. If you do understand this, great. Let's move on to the problem and the advanced substitution. So the problem in the book reads that Friar Tuck rode the 24 miles to the fair in Nottingham at a leisurely pace. He stayed too long at the fair and had to double his speed on the way back in order to get home in time. So here we see Friar Tuck is going to the fair, and then he doubles his speed on the way back home. So we have home, we have fair, and from this diagram we see that this is going to be a distance A is equal to distance B problem. So I'll go ahead and set up that equation. So distance A equal to distance B, and then I'll use this distance equals rate times time to change it again. So I'm going to have rate of A times time of A equals rate of B times time of B. Now I know what equation I'm dealing with. I can go back, read the problem again, and start looking for information as far as rate and time. So it says that he rode 24 miles to the fair. So we know that this distance is going to be equal to 24 miles. So one thing we can write is that rate of A times time of A is going to equal 24, and then rate of B times time of B is also going to equal 24. So that's useful information that can help us solve this as well. Again, because distance equals rate times time. Now it says he stayed too long and he had to double his speed on the way back in order to get home and if his total traveling time was 9 hours. So these are the other two tidbits of information that, that are going to help us out. One is total traveling time being 9 hours. So we know that time of A plus time of B is going to equal 9. And then we know that the rate of A does not equal the rate of B, because the rate of B is twice as fast, so I'm going to have to multiply rate of A times 2. So 2 times rate of A equals rate of B. So let's see what ways we can substitute this information into these three equations. Let's see here. If I change this time equation to be solved for time of B, then I will have two values for time of B. So if I rewrite this time equation to read as time of B is equal to 9 minus time of A, I get 9 minus time of A by subtracting A from each side. So I solve this top equation for time of B. So now that I have an equation solved for rate of B and time of B, I can substitute these values into this equation, and that will help me find an answer. So let's go ahead and start this substitution. So I'll write rate of A times time of A is equal to the rate of B, which is equal to 2 times the rate of A. And then the time of B, which is equal to, parentheses, 9 minus the time of A. So what I get here is some distributive property. I'll simplify that really quick. And then I've got 18 times rate of A minus 2 our rate of A time of A. All of that is going to equal rate of A time of A. And then here's where the advanced substitution comes in. We're going to use one of these, specifically this one. Rate of A time of A equals 24. So I'm going to substitute for both of them at the same time. So instead of writing rate of A time of A here, what I'm going to write is, let's go with red. Not sure why I'm drawing arrows. It just seems fun today. So I'm going to substitute rate of time of A with 24. So I have 24 equals 18 rate of A minus 24. Oh, I made a mistake. Hold on. Let me think here. Yeah, no, that's not minus 24. That's silly. When I substitute this would be minus 2 times 24, which is going to make this 48. So it would be minus 40. Wait, hold on. Before we bring a color into this, I have whiteout. It never happened. We're going to have minus 48. We'll keep simplifying, get all of our whole numbers on the same side, so we add 48 to each side. That cancels. 24 plus 48 gives me 60, 72. 72 equals 18 times rate of A. I'll solve by dividing each side by 18. That cancels. So then I get rate of A is equal to 72 divided by 18. 9, let's see here, 9 goes into 18 2 times, 9 goes into 72 8 times. So it would be 8 and 2, and then 2 goes into 8 4 times. So rate of A is equal to 4. Cool. Now, if rate of A is equal to 4, then rate of B, being twice the rate of A, is going to be equal to 8. So rate of B is going to equal 8. And let's see here, what else do we need to know? They want to know how fast did he travel in each direction, and what were the times. So now that we know the rates, we have to find one of the times. We'll just substitute these in here. So if rate of A is 4, we have 4 times T sub A equals 24. 24 divided by 4 is 6. So time of A is equal to 6, and then time of B, if they both add up to 9, has to be 3. There we go. And we just solved our advanced substitution distance rate time problem. If you have any questions, let me know on Moodle, and I will see you guys in class.